A little bit of Peter Gunn. Okay, so next strategy we're going to look at is splitting up fractions. So what we'll be doing with splitting up fractions is splitting up fractions. All right, this one you would probably have a really hard time dealing with U substitution. So what we're going to do is it's not a bad idea if you have a numerator that has two or more terms, you can try to split it up, okay? One of the things I see in this problem, and this is something you got to kind of look for, if you look at that x squared plus 4, if you were doing the integral of du over x squared plus 4, that can be really written as the integral of du over x squared plus 2 squared. That actually is 1 over 2, that number 2 right there, times the inverse tangent of 2 over x. Or x over 2, I got that backwards, sorry. Okay, like that. So we're going to look at that and kind of think about that as a possibility as we're working this out then. Okay, so a couple of things. The other thing I see is, like, if you look at x, if you were to look at the integral of x, just looking at this x over x squared plus 4, I could handle this with a u substitution, because if I let the denominator be u, then the derivative of the denominator is 2x. So see, that's probably the approach that we're going to take on this problem. So I'm going to erase these things, and we're going to kind of go through this then. So to start with, what we're going to do is we're going to break this up into the integral of x over x squared plus 4. That will be a standard u substitution integral. Then we're going to do the integral of 2 over x squared plus 4 dx. Then that's going to have a certain form to it like that. Okay, again, at the side of the paper, one thing I want to write down is this integral here. This is going to show up from time to time. So if you have the form of an integral, if you have du over a squared plus u squared, this is the way it's written in lots of integral tables. Okay, that's going to be 1 over a inverse tangent of u over a, and then of course plus c. So we're going to utilize that. The other thing that we'll be looking at is, of course, we know the integral of 1 over u du is natural logarithm of u plus c. So you got to learn to look for these kind of things. It takes practice. So what we're going to look at is, we're first of all going to start with, I'm going to call this integral number 1. We're going to work with that. Then we're going to work with integral number 2. So let's start with integral number 1. What I'm going to do is I'm going to let u be the denominator, x squared plus 4. Okay, so that denominator is going to be that. That's going to be u. Okay, now we're going to do du. We want du to be x dx or off by a constant. Okay, so du is going to be 2x dx. And then we can divide both sides by 2. So if you want to do that, you can do this in your head too. Just multiply them by a half. So you get 1/2 du is equal to x dx. Okay, so the numerator is going to be 1/2 du like that. Okay, so this thing is going to be transformed into this integral then. So I'm going to write this as, we're going to have u, and then we're going to have 1/2 du like that. Okay, we can pull the constant out. So that's going to be 1/2 du over u, which is 1/2 natural logarithm of u plus c. And then we can substitute back in. That goes there. Okay, and what we'll have is 1/2 natural logarithm x squared plus 4 plus c. So that's what the value of of that integral right there is. Okay, so that's half of the problem right there. Okay, now the second part, when we start doing the second integral, well, that's a constant, so that can be removed. Okay, so we'll have 2 times the integral of dx over x squared plus 4. Now I'm going to write that 4 as 2 to the second because it follows this form right here. Okay, so actually we're just going to follow this then. So this, bring down the 2, and then that's going to be 1 over a. Okay, a is this number right here. So basically, in this structure, your variable is x. Okay, then that really represents the a. A squared is 4, so a is 2. So what you would end up having is 1 over a, which is 2. So we're going to have 1 over 2. And we're going to have inverse tangent. And then we're going to have the variable over a. So the variable is x over 2 like that, and then plus c. Okay, notice that the 2's will cross out, and then we can put this together. So that will be the second part of the integral. We'll have plus inverse tangent x over 2 plus c, and that is the solution to that integral right here. That's a pretty tough one, but you got to see that you got to split the fractions. And you really got to pay attention to this form of the integral. See, when I saw x squared plus 4, I knew immediately that was an inverse tangent form of an integral like that. So that's how I knew to do what I did. Now, one thing I noticed on this, I don't need both of those plus c's. It's just one big plus c, so I'm going to erase that. And there's your answer, like that, okay? So that would be the answer to that problem. And you could check by differentiating, and it would take you back to the split form, which would eventually get you back to the original integral like that. Okay, so that's one example. I'm going to do the second example next. And we want to kind of look at what the form of this is. So I'm going to show you what we're going to look at in the table. Okay, so let me show you kind of what I see. The first thing that I notice on here is that denominator, and that directly tells me this. Okay, one thing I know is if I do the derivative of the inverse sine of x, that one is 1 over the square root of 1 minus x squared. Okay, so that would have been something that you learned when you were working with inverse sine. So when I see that, it makes me think that that has something to do with this problem. Okay, what I'm going to do again is I'm going to split up the fractions. So I'm going to write this as integral of 2 over square root of 1 minus x squared minus, then I'm going to do the integral of 3x over square root of 1 minus x squared. And then this one is going to be a u substitution, and that one's going to be a direct form of that. So we're going to split this up into 2 integrals. So we're going to call that integral 1 and integral 2 like that. Okay, so let's work with the first integral first of all. So I'm going to bring out the 2 and get 2 times the integral, I need to add my dx's there, of dx over square root of 1 minus x squared. Now see, that's automatic, okay? Since we know the derivative of inverse sine is this, then this is going to be 2 times inverse sine of x plus c. That's going to be the answer to that integral. Okay, now when we do the second integral, what I'm going to do is, if I look at this part right here, the derivative of x squared is 2x, and that's fairly close to that. It's going to be off by a constant. So that's going to be my strategy. I'm going to go ahead and pull the 3 out. So I'm going to have 3 times the integral of x dx all over square root of 1 minus x squared. Okay, so what I'm going to do is I'm going to let u be what's under the radical. So that's going to be 1 minus x squared. Du is going to be negative 2x dx. Okay, well that's close to the rest. So we need to make it that way. So I need to divide both sides by negative 2. So that's going to give, we can write this as negative 1/2 du equals x dx. Okay, so I've got everything ready to go on this now. That's going to be u. X dx is going to be negative 1/2 du. So we're ready to put together that u integral and integrate that then. Okay, so I'm going to have 3 times the integral. X dx is negative 1/2 du. Then we're going to have the square root of u. So we're going to write this as 3 integral. Now let's do this. We need to take the negative 1/2 out so you can pull that out. So you would get 3 times negative 1/2 integral of du over u to the 1/2 power. So we can use a power rule. So that's going to be negative 3/2 integral of u to the negative 1/2 du. And then you can use the power rule. Okay, so that's going to be negative 3/2. Add 1 to that integral. So I'm going to add 2/2. Okay, like that. Now remember, when you add, doing the power rule, you divide by the result. So the result of that's 1/2, so I'm going to divide by 1/2. Okay, so what I've got is negative 3/2. Since I'm dividing by 1/2, I'm multiplying by the reciprocal. Then I'd have u to the 1/2 plus c. Add 1 to the to the exponent and then divide by the exponent. The 2's are going to cross out. That's going to leave negative 3, and I'm going to change that back to square root of u plus c like that. Okay. Now to finish this up, of course, the substitution I used was u was 1 minus x squared, so I plugged that in. So I'm going to have negative 3 square root of 1 minus x squared plus c like that. Okay, so now I've got the results of both integrals. I've got the result of integral 1. I've got the result of integral 2. Okay, so that means what I'm going to do on that then, and remember we had a minus right there, so you've got to be a little bit careful about the sign on this. The result of this is going to be 2 inverse sine of x minus, bring that minus down. The result of the second integral is going to be negative 3 times square root of 1 minus x squared. Then we have to tack on the plus c. So the final answer should be 2 inverse sine x plus 3 square root of 1 minus x squared plus c. And then that should be the solution to that problem then. Okay, so that will be the final answer to the problem. So that's one more example of splitting up fractions. Okay, so that'll take care of this, this technique.